want to make a difference and want to make sure that this electrification, we are switching over from fossil fuel to electrification, but in that process, we don't make a mistake of swapping one set of problems with other set of problems, which become very difficult to solve. So we hope to succeed. We want to succeed. We have taken the first step in going from a lab to the prototypes in our pilot plant for the stationary storage, and we'll develop the other two. Their work is already in progress. There's one right behind another.
There's a growing ecosystem of alternatives to lithium-ion storage, and this is wonderful. We love lithium-ion batteries in the energy transition, but they have some fundamental problems, thermal runaway being perhaps the biggest. There are supply chain issues also. So that's a very good reason for our society to lean into alternatives. It's a both and is my mantra. I've had NZinc on the show with zinc technology. Today, we're exploring a manganese aqueous solution battery technology called Alsym Energy. And this will be diversifying all of the EV and stationary storage manufacturers' opportunities and alternatives. So I think this is a wonderful technology, but I'll let you decide. I would love to hear from our listeners about manganese. What do you think? And reach out to me. I'm Tim Montague. My guest today is Mukesh Chatter. He is the CEO and co-founder of a company called Alsym Energy. Welcome to the show, Mukesh.
Thank you so much. Glad to be here.
I'm Tim Montague, your host. Welcome to the Clean Power Hour. Please check out all of our content at cleanpowerhour.com. Please give us a rating and a review. That helps others find this content. So, Mukesh, tell us a little bit about yourself, your background, how you got into energy storage, and what you're up to at Alsym.
Sure. I'm an electrical engineer by training, worked on supercomputers and telecom space, and then did a number of startups. Some were successful, some were not. Had our own investment arm and did a number of investments as a reasonable size investor in startups. And about 10 years ago, I lost my mother to late stage ovarian cancer and realized that no amount of money could save her life. And that's when we changed the direction and said being on the treadmill to just keep generating more wealth is not the right answer. The answer is to help at least 1 billion people around the world and improve their quality of life. So that's what my personal focus is. My wife and I decided to pick a problem that's going to help at least 1 billion people. So in this case, we know that more than about 2 billion people around the world either don't have electricity or only get it part of the time because grids are very expensive to build. And unfortunately, off-grid storage, including solar panel and battery, for example, together cannot compete with the grid cost. So we decided to take the challenge which others were not willing to do and say that we are going to make a low-cost battery, which is high performance, lasts much longer, and is non-flammable and non-toxic, so that we could create this off-grid power storage, which is going to be cost competitive to grid power storage, so that 2.2 billion people at their homes can actually light things up at their home and come back from 19th century to the life of 21st century. So that was our mission. That's how we started. The mission has expanded since then as our technology became self-evident that technology has applications going beyond that into shipping and EV space as well. So that's kind of a brief
okay. background. And so you incubated the company at a academic institution, or tell us a little more about the history of the company.
Sure. So we are 4 co-founders. In fact, my wife was fifth one when we started, and about 3 years ago, she decided she wanted to do other things, focus on another company. So it's Professor Kripa Varanasi at MIT, Professor Koratkar at RPI, Rahul Mukherjee, who's our head of R&D, and myself. So 4 of us. So once my wife and I started the mission to say we got to build this technology, we were looking for the right people who could help our cause. A lot of people did not want to take this as a challenge because they thought it was too complicated, it was too difficult to meet. So but then we met with Professor Varanasi at MIT and Professor Koratkar, and one thing led to another, and they said, let's take this challenge. It's very important, and yes, it's doable. So that was about 7.5 years ago. And here we are actually, where we have product that's transitioning for stationary storage from lab into the prototyping plant, and we are very delighted with that.
And so the initial market that you are targeting is exactly what?
First market is stationary storage. 6 months later, it's basically we will have a product that's will be transitioning from lab going into prototyping plant for shipping, which is higher performance. And then the last piece, the third piece of the puzzle is for the EV, which is probably a year away at this point.
Well, when you say stationary, tell me more. What, commercial, industrial, or residential, or just grid? There's many segments of that market, so to speak.
It's pretty much all of the above, and I'll tell you why. I don't want to sound like it's a solution for everything, but since we are high performance and low cost, okay, what that allows us to do, and by the way, we can sustain the duration for a long time. Our self-discharge rate is very low, that even after 30 days, we are down only by 10%, which means we are retaining 90% of what was stored. So we not only play in that niche market, but we also play across the board in the broader market where our cost basis is low and it's non-flammable. And as you know, I'm sure that in the stationary storage, the only option today realistically is either people do lithium ion based stationary storage and the related issues that crop up, flammability, for example, what happened with the Megapack fire in California or in Victoria in Australia and other things. And there's also the need for significant paraphernalia around air conditioning and whole nine yards. So those are a set of issues that are generally well known on that side. But the alternatives are, so either it's high cost, high performance, flammability integrated into it, or it's low cost, super low performance, and non-lithium ion based solution. But there's nothing that bridges the two. And that's the market where it's a low cost, high performance, and yet non-flammable. So that's the market we are going after in stationary storage space, both commercial, industrial, and potentially residential down the road.
And when you say low cost, well, how do you define low cost?
We will be, put it this way, we will be, if we need to be, we could be half the cost and we'll do just fine of existing lithium ion solutions.
That's your goal, is to be half the cost of lithium ion.
Yes, we could price things at half and we'll still be fine. Okay.
So let's talk about the technology. What exactly are you doing? You have an aqueous solution. What is an aqueous battery, and to the extent possible, how does it work?
Sure. So listen, our electrolyte is mainly water as opposed to primarily water, as opposed to, again, lithium ion is the best standard to compare, where it's largely organic electrolytes. Right? If you look by your battery today from LG or Samsung or anybody, they all use organic electrolyte. Those are the ones that are the flammable in addition to lithium and other things. We own our primary component, primary electrolyte, primary element solvent is water, which is much cheaper, non-flammable by definition, and easy because it doesn't catch fire and things like those. Second thing is one of our electrodes is primarily manganese oxide. Operating word is primarily. We don't use any lithium. We don't use any cobalt. Okay, that's important. So no issue related to be it human rights or be it cobalt poisoning, for example, that just happened in Victoria in Australia, where 2 of the firefighters got cobalt poisoning. So we don't have neither of those. The other electrode is primarily metal oxide, and electrolyte is aqueous. So again, manganese oxide is available readily all over the world in abundance. So supply chain is not constrained by 1 or 2 countries. It's very broadly available. The other metal oxide is equally broadly available, including in the United States, and water is available everywhere. So it meets all our key requirements. That's how we picked the material, because we had the luxury, unlike lithium ion batteries where chemistry is fixed. All you're doing is working on further and further enhancements, going for higher and higher hanging fruit, as opposed to us who came up with a brand new chemistry, doesn't exist in otherwise. And our criteria for picking the material, they have to be low cost. They have to be readily available. They cannot be flammable, and you cannot produce hydrogen fluoride or hydrofluoric acid if it mixes with moisture to cause the issues. So those were the guiding principles, and that's how we approached it.
Yeah, I mean, I'm glad you mentioned availability, right? Like, lithium is super abundant in the universe. It's the third most common element. We don't have enough lithium mines spooled up on Earth currently to meet demand, so that's a problem. So, what is the situation with the components of your battery? How scalable is the manufacturing?
So those mines exist, and no material that we are using, even if we put it this way, we will not be 5% of the overall market, even if we supplied in hundreds of gigawatt hours. So that's a non-issue. And while lithium is readily available, I think it's a misnomer to a degree, very large degree. In fact, I think it's not something that people have clarified. Nobody wants a lithium mine in their neighborhood within 20-mile range. The destruction, the poisoning that happens of the life form, and that's why South America, there's such a protest in some of the areas where the mines are, because the water is badly contaminated, air is badly contaminated, and underground water gets impacted. So the question is, do I want it? I'm in Massachusetts. I can tell you that there's no way on earth the state of Massachusetts is ever going to approve a lithium mine in this state. Is there lithium in Massachusetts, just like, as you said, widely available? Sure. But will anybody approve it? Chances are no. So it's going to, where is that going to land up? Largely in the poorer countries, like South America in case of lithium. There is lithium in Nevada, for example, lithium in Carolinas.
Yeah.
So what I'm hearing is that the permitting process, from the start of the permitting process to end of production, is a 10-year cycle.
Yeah.
And the other danger people may or may not appreciate it, in those 10 years, as it starts and the production goes on, if alternative technologies like ours come along, and now you don't need those mines, then what happens? So now we need in the United States, right now we are less than 1% of lithium, cobalt, and nickel, what we produce today. If we wanted to go by Inflation Reduction Act and get all of it made in North America, for example, we will need probably a couple of 100 times more mines than they exist today. And once those mines start, the contamination and all the protection that has to happen, and in fact, we are in Woburn, Massachusetts, which is very famous for W.R. Grace, and it's the whole contamination that happened. So I can tell you that we certainly have a heightened sensitivity to what happens when you put up these contaminations that happen, and how many years it takes, and how many people with the cancers and other diseases, what happened, and it's a well-known history for Woburn, Massachusetts. So I think there are serious issues. So I don't think it's fair to say that lithium is abundant on Earth, so let's do it.
No, not at all. But you are making some very, broad claims. I have nothing against manganese. Okay, I'm cool with manganese. It's very common. It's not apparently common in the U.S. though. So, yeah, I want safer, healthier. I want a safer, healthier future for humanity. That is one of the missions I'm on with the show here. And so I love that you're taking an environmental justice stance and, trying to look out for the little people and bringing electrification to rural parts of the world that don't have grid electricity. That is a must do. And solar and storage is clearly the way to do that. You need affordable storage. To keep the lights on, when the sun goes down, and you're tackling that. I love it. So just real quickly though, when you do this side by side availability, scalability, you have no concern about manganese, our ability to mine enough manganese. Is that what I'm hearing you say?
Manganese is very, very widely available. It's available in India, it's available in Australia, it's available in many other parts of the world. This is manganese, there's no shortage of. And one thing we share our goals. I want to make sure that, one thing I want to point out, we share our goals of, as you said, zero fossil fuel and electrification. And I'm not saying lithium-ion batteries should disappear. Don't get me wrong. These things will coexist. All I'm saying is that if all the 90 million vehicles that are sold every year, okay, and all the storage needs that exist, especially on stationary side, market is exploding after what happened in Ukraine, and the Europeans are they don't want to be dependent on any country for energy anymore. They want to build their own intermittent sources of power, and they want to put the batteries. If all of that goes into production, the amount of lithium that's needed, amount of cobalt that's needed, and is going to be far, far more than what humanity can tolerate in terms of the toxicity and otherwise. And
but if you can make a manganese battery for half the cost of a lithium battery, that is going to be disruptive. And if I'm an automaker, I wouldn't consider using a lithium battery if I can find, because the battery is a major expense, and it's also a major part of the weight of the vehicle. But so on an energy density, volume basis, all of this, you're checking a lot of boxes. Why wouldn't you become a dominant technology? Why wouldn't you eclipse lithium?
Look, I mean, that's what we aspire to, right? That's what we want to do, want to make a difference, and want to make sure that this electrification, we are switching over from fossil fuel to electrification. But in that process, we don't make a mistake of swapping one set of problems with other set of problems, which become very difficult to solve. So we hope to succeed. We want to succeed. We have taken the first step in going from a lab to the prototypes in our pilot plant for the stationary storage, and we'll develop the other two. Their work is already in progress. They're one right behind another. And I think at the end of the day, no one technology is going to dominate. And I certainly would not bet against human ingenuity. I'm absolutely convinced at this point there's always going to be some garage somewhere working on yet another alternative that's better than ours. So I think this is the fair part of competitive process, and that's what makes this country so unique and exciting, actually.
Hey everybody, thanks for listening to the Clean Power Hour or viewing it on YouTube. We do have a great YouTube channel. If you're not subscribed, please go to cleanpower.group and hit that YouTube icon and subscribe to our channel. Of course, you can find all of our content on your favorite audio platform as well. So please give us a rating and a review. Back to the show. I'm a little confused. I just have to be honest. Why you don't give me a direct answer, though, to that question about disrupting the lithium market. You say you want to disrupt the market. You say you can create a product that is half the cost, and yet you don't say a direct yes to, well, yes, we're obviously going to replace lithium ion. So I just from a prosumer perspective, it seems like you're on that path, and that's very intriguing and interesting. So what else should we talk about? I don't know, okay, stationary storage and then mobile storage. Right now, the bulk of the batteries are going into mobile storage, and that's a challenge for the supply chain for stationary storage, right? There are major supply chain pinch points. Installers and developers are migrating from manufacturer to manufacturer right now because of supply chain issues. Tesla's a great case in point. It's very hard to get Megapacks, and so we're always casting about for alternatives, even though Tesla makes a very good product, not a perfect product. Sure. And they are one of the major players in commercial storage. And but tell us more about what your vision is and how this, if you're in the market for storage, why should our listeners pay attention to Alsym?
Sure. So I also want to answer your previous question. My apologies if it came across like I wasn't directly answering it. Let me put it this way. We planned to be disruptive. We are in the process of developing product to be disruptive, and we shall be disruptive. So, make no
all right. Thank you.
That's what we are going to do. That's what the team is here for. I just was taught when I was growing up not to blow my own horn, so I'm trying to be, it's hard to disrupt that cultural habit, if you will, but that is the fact. So as far as how it impacts, look, Tesla is a great company. They've done a wonderful job. Single-handedly, they've done something which others could not do. The fact is that the EVs existed. I mean, Jay Leno has a car which runs actually on batteries, I think circa 1932 or something like that. I saw it on TV the other day. So look, EVs have existed, but the reason world went to gas-based cars is because electricity wasn't readily available all over the country at that time. So we are making a full circle, whether it was in 1930 or 1920.
Yes, we are.
Remember. So the point is, but what Tesla did, single-handedly make this technology viable and attractive to people, where people are receptive to it. And they've done a wonderful job, and one can never take the credit away from them. It's like building a wonderful rocket that takes off going to moon. But I believe because it's based on lithium batteries, the rocket is going in the wrong direction. And what we are doing is to put it in the right direction. But the fact that somebody developed that technology, a car, which is more important, and has been able to have the reception. So I think that's awesome. Clearly there's a shortage on the stationary storage side, but there's a shortage actually on the automobile side as well at this point. And so part of the challenge is going to be, if one technology with one product, with one set of materials is deployed across the world in every segment, from electric vehicles to trucks to stationary to all the ships, and going even further, home applications, others, I don't believe such a material exists on Earth. So there will be multiple technologies, they will exist, not to stress one particular material. So that's the first thing. Second thing is what we are doing internally. For each of the three segments, we are deliberately picking the materials so that we don't stress one particular material. There will be, in fact, a series of solutions, 2 or 3 solutions coming from us, so that no one particular material is stressed. Yeah, so I hope that I answer your question in that context.
Well, yeah, I mean, diversifying the technology is a good thing, right? We want to have more access to batteries, bottom line, and safer technology, great. Healthier technology, great. I don't know what the issues are, what the environmental issues are with manganese mining. I hope they're benign, because we need a lot of storage, clearly, and so mining is just part and parcel. We need a lot of aluminum. We're already using a lot of aluminum and steel. Those are also big holes in the ground. So, but I had a question about form factor, and then to the extent possible, a little more about the market. Are you a pouch or a cylinder, or what is the form factor of the product?
So our initial form factor is pouch cell. Okay. It's about 320 centimeters square. I could actually show you. Would you have, please, if you don't mind? So I could show you actually what we are producing from our prototyping plant. And this is a real cell, actually. So this is what it looks like. It's exactly 320 centimeters square. Okay. And we have built 5 layers so far. We'll be building about 28 to 30 layers. And our limitation today is not that we cannot build 30 layers. Our limitation is we don't have enough power coming into the building to be able to produce enough material. There's a massive shortage right now. It takes our local utility company anywhere between 9 to 12 months to provide us additional power coming to the building. We have 1,700 amps, and what we need is 4,000. That's our challenge.
Yeah. So you mentioned in the pre-show that you're taking pre-orders. Who are the early adopting industries, and what are the applications?
Sure. So we have a pre-order from an Indian automobile manufacturer, and which we have already announced, 3 gigawatt hour per year for 3 years. We have a pre-order from a shipping company, Nissan Kaiun and Synergy Marine. Nissan Kaiun is the largest ship owner in Japan, and that's 1 gigawatt hour per year for 3 years. Again, these are the minimum volumes. And we are engaged in conversation as we speak with a large stationary storage company to provide, again, in the gigawatt hour range for their storage.
Let me stop you for a second. So I understand you are equivalent to a CATL, though, right? You are making the cells. You're not providing an end-to-end solution necessarily. Is that what I understand?
That's correct. That's correct.
Yeah.
We are working with a partner. We're discussing a partnership with a company that will take our cells and create a package solution like a container, for example. So our first release of the product will have 2.4 megawatt hour per 40-foot container. The next release of the product, we expect to do about 4.8 megawatt hour per container, DC container, for example. So and the packaging and the management system, EMS and BMS, that will be done by the partner initially. Later on, we may develop our own, but time will tell on that. Right now, our focus is to deliver the battery and the commercial at the commercial scale.
And duration-wise, it is this relatively short duration, right? 2 to 4 hour duration.
No. It could be week. I was mentioning earlier, our self-discharge is less than 10%. What it means for over 30 days. What it means is that we can go for 30 days while retaining 90% of the capacity that exists. So yes, we are long duration as well. We are not a short. We could do 2 hours, we could do 4 hours, we could do 40 hours, and we could do 400 hours. It's basically about a month. I mean, lithium batteries, by the way, their self-discharge is 10%. So lithium batteries could also provide long duration. The problem is that they're very expensive. That's the challenge.
Well, right. I mean, if you just stack more of the physical asset, you can create more duration, so to speak, right? But
not necessarily. So let's take a simple example. I got 1 kilowatt hour battery.
Okay.
If that 1 kilowatt hour battery still retains 900 watt hour at the end of a month. So and then it can deliver at any rate you desire.
But by duration, I'm not referring to the discharge when not in use. I'm referring to its ability to service a load for an extended period of time.
Sure. So lithium battery could service a load for a long time. If I'm lighting up a 10 watt hour bulb, right, on a 1 kilowatt hour battery,
right,
for a lithium battery, you
but
can light up that bulb for
there's
many
a difference
hours.
Between a Megapack and a pumped hydro facility. Pumped hydro is long duration. A Megapack is short duration. It is designed, it's engineered, it's cost effective for a 2 to 4 hour application. And so that is a market segment. That is what I'm referring here to, is the market segment.
Sure. Look, it's a cost issue, not the technical issue. So I just want to make sure I can use a Megapack today if somebody wanted to do it for a longer duration and provide. The challenge is it's very expensive. So the point,
and very large.
Well, I mean, if you look at, for example, Form Energy, and if you look at their 2.4 megawatt hour equivalent battery, it will be several containers,
yes,
not one container.
Correct.
So in terms of large size, a lithium battery actually does far better. The problem is the cost. It's not the dimension. Look, volumetric density lithium ion is the best. There's no question about it. If you look at from its ability to retain charge over a longer duration, it's great. Could it also support a smaller charge delivery if somebody wanted it? Yes, it could do that. The biggest problem is the cost and flammability.
Yeah.
So the niche people have been talking about long duration in a way. What that is how does one deliver a very low rate of electricity over extended period of time at a very low cost? Well, so that's really the long duration.
I'm not aware of a lot of applications for that. We need to power facilities, buildings, factories, homes, right? Overnight.
Sure.
Right.
So we could do that easily.
Charge up during the day, discharge over the night. That's not a long duration solution. That's you're using 2 to 4 hour technology, stacking it, and meeting that need, and that's fine. So anyway, we need lots of storage. Sure. We would just have 5 minutes left, so let's be selective about how we wrap this up. What is the status of the company? How are you planning to scale? Is it a U.S. only approach, or are you going to prop up, gigafactories in other places? Tell us a little bit about that big picture.
So we're a small company. We'll be partnering with a third party for manufacturing of the product. As a startup company, it's difficult for us to set up a 50 gigawatt hour plant. In fact, I'm not aware of any startup who's actually setting up 50 gigawatt or be above plant. So for automobile applications, we'll be partnering with the auto partner to manufacture the batteries. For stationary and shipping application, we'll be working with third-party contractors, third-party contract manufacturers, which are beginning to come up with the Inflation Reduction Act that has done a wonderful job in terms of encouraging manufacturing in the United States.
For sure.
Right? So that's coming up. So we'll be partnering with one of those prospects to deliver the goods on that side. And by the way, we can repurpose the existing lithium-ion plant as well for our technology. So that makes it somewhat easier. And so I think... So our plan is to do as much as we can in the United States. The plan is not to set up plants all over the world. That's the desire. Or at least set it up in the countries where there's respect for IP.
And how long do you think it'll be before we're seeing your technology actually, in the built environment?
Sure. Our plan is to be in high volume production by second half of 2025.
Okay. What else should our listeners know?
I'll tell you, these are exciting times we are living in, right? There are a lot of challenges after what happened in Ukraine war. The good thing it has done is it has spurred, it has activated this thing in the mind of people. This is a real problem we got to solve. And I think to that extent, the awareness on a larger part of the public is very, very high. So I'm thrilled about that. What we are short of is typically the solutions. And we are clearly a step in the right direction, but it will also spur more innovation. At the end of the day, anybody who's trying to reduce the fossil fuel and replace it with electrification, we are collaborators to that extent as far as the larger planet goes. Right. So my message is basically at the end of the day, look, yes, we will be economically successful. I'm very confident of that. But at the same time, the larger goal is not just to be economically successful. We started out with trying to help billion people. We'll definitely light up those homes, but also we got to reduce the carbon emission. So I think we are on our way, and we'll continue to do that.
Yeah, I mean, it's interesting. We've actually been in the energy transition now, the clean energy transition, for 50 years. It's just not until really 2010 or so that the cost technology curve really hit that inflection point, and now it's going mainstream. And it's just a question of, can we make the transition fast enough now to prevent runaway climate chaos? So how can our listeners find you, Mukesh?
Best thing will be to, right now we are so small. We have limited resources. Best thing is to coming to us through the internet. We have a form on our website, and they could definitely reach out. And our head of marketing, Matt West, will make sure that he responds. We would love to hear from prospective partners or customers and work with them.
Yeah, the website is alsym, alsym.com. And you can find all of our content at cleanpowerhour.com. We have a great YouTube channel. Please subscribe to the channel. Just hit the YouTube icon. That will take you right to the YouTube page. And if you're listening on audio, we're on all the audio platforms. Please give a rating and a review on Apple or Spotify. And especially a review would be very helpful. So thank you all for listening. I look forward to seeing Alsym flourish and bringing some significant competition to the lithium-ion market. Really excited for this. And thank you so much, Mukesh Chatter, CEO of Alsym Energy. Thank you.
Thank you so much, Tim. Greatly appreciate the opportunity and what you're doing towards the clean energy. So thank you so much.
I'm Tim Montague. Let's grow solar and storage.